So in the lecture 3 of electricity, we are going to study about the Ohm's law. Now, this law was given by the great scientist George Simon Ohm. The Ohm's law gives a relation between two electrical quantities, that is, the potential and the current. So, in order to have the potential difference, we connect the bulb through wires across a battery which is having a positive terminal as well as the negative terminal. The positive terminal is at the higher voltage and the negative terminal is at the lower potential. Now the current flows and the bulb glows. Right? Put two batteries, the more current will flow. Put three batteries, more and more current will start flowing. And Ohm's law actually studies a relation between the potential difference and the current. Now it says that the current flowing through the metallic conductor is directly proportional to the potential difference across the ends, provided the temperature and other physical condition remaining the same. Right. This is what exactly is Ohm's law. The length of the conductor if it remains constant, the area of cross section if it remains constant, and the temperature if it remains constant, materials is the same, then the potential difference across the ends of the resistor is directly proportionate to the current flowing through it, and this V by I becomes a constant. Now this is exactly the Ohm's law. Now this constant is called as the resistance of the wire, right? Now if you simplify this formula, what do you get? Cross multiply V by I is equal to R, or V is equal to I multiplied by R, where I is the current and R is the resistance. Hence we can write V is equal to IR, and this exactly is known as the Ohm's law, right? Okay. Now from Ohm's law, we got a new concept which is called as the resistance. Now what is this resistance? We all know that in the cross section of the wire, there are atoms as well as the free electrons. The free electrons keep on moving, and if you connect it across the battery, we know that all the electrons move in the different direction, but overall there is a drift towards the positive terminal of the battery. You can see all the electrons, they get drifted towards the positive because electrons are negative, hai na? So when atoms are more, or if you have got the free electrons, the obstruction to the flow of them is more, then we say that the resistance of this conductor is more. That means the current is less. If the resistance is more, then the current will be less. Okay, now when the atoms are less, so the obstruction is also less, so the current is more. So if the resistance is small, then the current will be more, right? So the property of the conductor due to which it opposes the flow of the current is called as the resistance, right? So resistance is the property which actually obstructs the flow of the current through it. In this case, we are talking about very specially about the conductors. In fact, if you flow the current through the conductor, there will be an obstruction. But if you flow it through any other substance like gas or maybe like aqueous solution or maybe molten salts, then also it offers the resistance. But here I'm talking about only the resistance which is given by the atoms of the conductor to the flow of the current, which is through the flow of electrons, right? Okay. Now, once you have studied it, we need to understand what exactly is the unit of resistance. The unit of resistance is ohm. Ohm, it is given in honor of the great scientist we talked about, that is George Simon Ohm, because he actually made the Ohm's law, right? Okay, now the resistance, if it is R is equal to V divided by I, and that ohm is the unit of resistance. So what is 1 ohm? If you want to define 1 ohm is equal to 1 ohm, 1 volt divided by 1 ampere. That is the definition of 1 ohm, right? If the potential difference across the two ends of the conductor is equal to 1 volt and the current through it is equal to, say, 1 ampere, then the resistance of the conductor is said to be 1 ohm, right? This is the definition of 1 ohm, right? Okay, now what next? Factors affecting resistance. Now, what are the factors affecting the resistance? The factors affecting resistance are the length. More the length, more is the resistance. Area of cross section, and let me write it symbolically. R is directly proportional to length, and the resistance of the conductor, it is inversely proportional to the area of cross section. Of course, it will depend upon the material and also the temperature, right? Now, we have got, if there is a conductor, as you can see here, then more is the length, more is the atom, so the resistance also increases, but provided the area of cross section is less. Now, how it depends upon the area of cross section? We know that somebody has to get inside the train, तो छोटा सा दरवाजा है तो रेजिस्टेंस ज्यादा होगा, अगर बड़ा सा दरवाजा है तो ज्यादा लोग एंटर कर पाएंगे, रेजिस्टेंस कम हो जाएगा. So if the wire is thicker, what happens? More electrons can flow and the resistance is less. So the resistance is inversely proportionate to the area. So thicker wire will have lesser resistance. So if the cross section is the same, it will depend upon the length. And if you only consider the area of cross section depending, keeping the length as constant, it is inversely proportionate to area. Combining these two, we have the resistance is directly proportional to length and inversely proportional to the area. And the third important thing is it will depend upon the nature of the material. This is called as the specific resistance, or it is also called as the resistivity of the material. It depends metal to metal, it will vary, right? It is pronounced as rho, right? So what is the formula? Yes, R is equal to rho L by A. That is the formula for the resistance. But here we are not considering the temperature. Now let us find out the unit of resistivity. R I know is the resistance, A is the area, and L is the length. Okay. Now if I want to replace all of them by the units, we know resistance has got a unit of ohm. Okay, what is area? Meter square, baba. Length का क्या होगा? Meter होगा. Now cancel meter square and meter. What will you get? So the unit of resistivity is ohm meter in SI unit. Okay. Now we understood what are the factors which affects the resistance, and we also studied about the unit of the resistance, which is ohms into meter. Now the temperature, the another important is, see, if you talk about the length, if you talk about the area of cross section, if you talk about the material, this is the formula you get. But what about the temperature? If you increase the temperature, what happens? On increasing the temperature, the resistance also increases. Now there should be a formula for that. Suppose R naught is the resistance at T1 degree centigrade and RT is the resistance at T2 degree centigrade, then RT is equal to R naught 1 plus alpha T2 minus T1, where alpha is the temperature coefficient of resistance. Simply it says that if you increase the temperature, the resistance of the conductor will increase. And if you reduce the temperature, what will happen? The resistance also goes on decreasing. Now think of it. If the temperature goes on, decreasing, almost it is going to 0 Kelvin के आसपास. तो भैया resistance खत्म हो जाएगा. This property is known as superconductor, right? And it is a property wherein you are going to use this particular principle for the transmission of electricity, because there will be no loss. And the research have been done, and they are used in supercomputers and many other places. Okay, interesting, na? Go find out more about it. Now we'll talk about the practical understanding of the resistivity. Now, if I have got an electrical circuit, right? I've got a positive terminal of the battery, here the negative terminal. I've got an ammeter connected to it to measure the current, and I've got 2 points A and B. Then if I put a copper wire, the circuit is complete and I could see the reading in the ammeter, whatever it is, if the current is on, right? Okay, now if I take another wire which is made up of aluminum, again the circuit is complete and the current reads is 20, right? Okay, now what happens if this particular gap is like if you put a glass rod is a bad conductor of electricity, the circuit is not complete and no current flows, and the ammeter will show zero current. Means zero current means what? The substance is not a good conductor of electricity. Put rubber, again the same thing, right? So what are the factors on which the resistance depend? The resistivity of is the specific property of a material. Different materials have got different resistivity, right? Copper has got very little resistivity. Silver has the least. And if you put aluminium, it is more than that of copper. So more, अगर resistivity अगर ज़्यादा होगा ना, तो automatically क्या होगा? Current आपका कम हो जाएगा, ठीक है? तो ये ऐसे हम समझ सकते हैं कि resistivity affect करता है resistance को, right? Okay. Now let us ask a few questions. What factors does the resistance of the current depends? Answer. Resistance of the conductor depends on its length, area of cross section, that is thickness, nature of the material, and the fourth important is temperature. Okay. आपने तो मेरे से पहले आंसर बोल दिया. Very good. Now there is a question for you. How does the resistance of the wire change when the length is tripled, the diameter is tripled, material change to one whose resistivity is 3 times? अरे तीनों तीन बार करना है, तो चलो करते हैं. Resistance, I know the formula is rho L by A. Fine. इससे क्या पता चल रहा है बच्चों? इसमें ये पता चल रहा है कि भैया रेजिस्टेंस जो है ना, इट इज डायरेक्टली प्रोपोर्शनल टू लेंथ. लेकिन इसमें क्या क्या कांस्टेंट रहना चाहिए? एरिया और जो मटेरियल यूज किया गया ना, इन दोनों को मुझे कांस्टेंट रखना पड़ेगा. तो क्या करना होगा? If L is tripled, the resistance is also tripled. Okay. Now let us talk about how the resistance depends upon the area. Look at the formula again. This R is inversely proportional to area. Okay, bhai. Now, what is the formula for the area? We know that the area is equal to how much? It is pi r square if r is the radius. Or we can say the diameter, pi diameter r is equal to d by 2 into 4, or you can say it is pi d square divided by 4. Okay. Now let us consider this. Resistance of a conductor is inversely proportional to the square of the diameter. कैसे आया? हाँ बता रही ना, एक मिनट. R is directly proportional to area. एरिया की जगह मुझे क्या लिखना है? पाई डी स्क्वायर डिवाइडेड बाई 4. अरे प्रपोर्शन तो करना है, पाई इज अ कांस्टेंट ना, 4 इज अ कांस्टेंट ना. इसका मतलब क्या है कि रेजिस्टेंस जो है इट इज इनवर्सली प्रोपोर्शनल टू डी का स्क्वायर. अब हमने क्या करनी है भाई? डायमीटर को ट्रिपल करना है. तो ये जो आर डैश आएगा वो कैसे होएगा? तो बोलेंगे आर इज इनवर्सली प्रोपोर्शनल टू डायमीटर को 3 गुना कर दो, स्क्वायर कर दो, तो क्या आएगा? आर डैश की जो वैल्यू है इट इज इनवर्सली प्रोपोर्शनल टू 9 टाइम्स ऑफ डी स्क्वायर. अरे इसका मतलब है कि जो रेजिस्टेंस है ना 9 टाइम्स कम हो जाएगा. ठीक है, इट विल बिकम 1/9 टाइम्स. ओके, नाउ द नेक्स्ट वन वी आर गोइंग टू कंसिडर दैट इज द, मैं यहाँ अलग से लिखते रही हूँ बच्चों, यहाँ देखिएगा, R is directly proportionate to rho यानी कि resistivity. Now I am going to change the material of the wire, keeping the area as constant, the length is also constant. What are the fixed things? That is the length of the wire, area of the wire, that is kept the same, but only the material is changed, and the new material, it will be also proportional to r dash, but it is given that you have got this rho dash is equal to 3 times of rho. So what happens to the new resistance? It will become directly proportional to 3 times of rho. So what will happen to the resistance, bachcho? If the resistivity is tripled, then the resistance also get tripled. That's it. Okay, simple problem, right? Okay. Now, will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? मोटा वायर में ज्यादा करंट जाएगा या पतला वायर में जाएगा? चलो देखते हैं. When connected to the same source, that means same battery, the current will flow more easily through thick wire than the thin wire. कारण बताओ, कारण बताओ. थिन वायर की रेजिस्टेंस ज्यादा और थिक वायर की रेजिस्टेंस कम. The resistance is inversely proportionate to the area. That is the reason. ठीक है? Okay. Now, thanks for watching, बच्चों. Go do the homework. And of course, if you have not subscribed, go and subscribe now.